All right, we're going to go through a little bit of what a translation, what it means, and just the 3 different ways to show a translation. And then we have 2 examples we're going to do. All right, so a translation, we're going to start with the definition, means to change an object. Because remember, a transformation means to change. So we're always going to be changing objects. Change an object by moving all points. And I'm going to capitalize all and underline it. That's really important that we do all the points because the whole thing has to move. Change an object by moving all points. In the same direction. Good morning. Okay, we're right in the starting notes if you want to open up. And if you don't finish the definition, just skip a couple. Yeah. For the same distance. So kind of a long definition. Pretty much it just means to move it. Okay, so as I'm walking around the room right now, I'm translating my body. I'm literally just moving my whole body. I'm not leaving my hand over there. I'm just moving as I go, the whole thing. If we translated seats, that would mean we'd get a new seating chart, right? We'd move around to different seats. All right, good. Come here, I'll put your phone away. All right, we have 3 ways to do this. One way is in words. When we use words, what words do we use for directions? If you're telling someone to move, what would we say? Which ways can you move? Left. Okay, if you're like me and you struggle with directions and you want to draw an arrow to the left, just remember that's left. Sometimes I think left is right and right is left. Okay, so left, what's the other way of left? Right. And if you want to use that arrow to show. So we're going to pair one of those words and what's our other direction that we can move on a graph? Up and down. So we're going to combine those. Now, in real life, in the 3-dimensional world, what other direction can we go? Yeah, well, diagonal, or you can go forward, right? We can actually move forward and backward. On a graph, we can only go up and down, left and right, because it's only 2-dimensional. So in 3-dimensional, we have a couple more options, but with our 2-dimensional graphs, it's just up, down, left, and right. All right, the next way we can show it is using a vector. Those of you that have watched Despicable Me, the bad guy in the first one is named Vector. You guys remember him? He wears a jumpsuit. It's orange. The orange jumpsuit, and he has like a really bad haircut. He's like, Vector! Freeze ray! I don't know. Okay, the reason he's called Vector is he says, because I go in all directions. Vector tells us a direction. It tells us a movement. All right, for a vector, we use these little weird parentheses that are pointy. These pointy parentheses. Okay, shh, Carter, CJ. All right, in the vector, it's kind of like an ordered pair. What usually comes first in an ordered pair? X. And then what comes next? Y. But this ordered pair, it's not an ordered pair. It's not a location on the graph. It's telling us movement. And that's why we like to use those little corner parentheses, because it's not actual point. The X tells us movement. In which direction is the X going to tell us where to go? Left or right. How will I know if the number is showing me to go left? Close. When I go left, it's actually negative. When I go right, it's positive. So if it's a positive number, it's telling me to go to the right. If the first number is negative, it tells me to go to the left. Okay, and then same idea with y. What does y tell me to go which directions? Up and down. What would positive tell me to go which direction? Up. And negative would tell me to go down. Here you go, Keela. Good. All right. So we have vector. The last thing that we can do is, they called it a mapping in the video. I like to call it arrow notation. It's the same thing. I call it arrow notation specifically because that is what Alex calls it. So just naming it what you're going to see it in your practice. You might also see it as a mapping. Mapping kind of shows where it's going to, how it's changing. So arrow notation is actually going to start with a point, and we always start with just x, y. We aren't naming an actual point. We're never actually going to put numbers there. We literally just write x, y. And then we're going to do an arrow, hence the name arrow notation. And this is showing us the transformation. How is it changing? It's changing to x, and it might be plus something or minus something. And then y plus something or minus something, depending on which direction it's going. All right, we have two examples. For your examples, you're going to do a glue in because I did some graphs. There's glue in your bins. I don't even have glue. Oh. I'll get you guys glue. All right, so go ahead and glue this in, and then as we work, you want to use one colored pencil or one highlighter. You're just gluing it at the bottom of your page. Yeah.
So always if you get this notes,
Alright, I know the glue sticks are sharp, so come around this more. Alright, if you want to pick out one colored pencil to use, you can do that. Yeah, you would do this. Yeah. Yeah. Yes. Alright, I'm going to go around with glue sticks because I know some things are missing them. You should have two in each bin, so if you only have one, let me know. I get that one when you're done. Alright, so I'm going to use, I don't know what color. I'm just going to use a sharp color. I'm going to use, should I use yellow, brown, or red? Blue? Okay, I'll use blue. Camille says so. Alright, so get that glued in. Grab out one colored pencil. Give you about 15 more seconds. What? Are they not? You have a bunch right there. You just need one. They're right there. Just use one of those. You just have to write with it a little bit. You'll be good. I gotta refill those bins. That's my plan to do today. All right, we have two examples here. The first example, we're going to be doing the translation. They give us the pre-image, the before, and we actually need to graph the image, the after. The second one, they give us two, so that's going to be a little bit different. We're actually going to have to fill this part in. So this one we're kind of doing both. All right, so it tells us in words what's happening. It tells us we're going to go 3 units left and 1 unit up. So again, I have tough time with directions, so if you want to say left, if you want to put that arrow there, 3 to the left, and then 1 up. So let's express that in 2 other ways. We have a vector and we have arrow notation. So for the vector, we're going to do that little pointy parenthesis. And we want to start with the x, the left and right. So what number is going to be my first number? 3. And is it going to be a positive 3 or a negative 3? How would I show left? Yeah, left is a negative direction. So negative 3. And then what's my y going to be? 1. Positive or negative? Positive because it's up. Good. Okay, and that's our vector. Negative 3, 1. Okay, and then we have arrow notation. Arrow notation, they already started with the x, y, and the arrow there, so we just need to fill in the rest. So with the x, am I going to be adding 3 or subtracting 3? Subtracting, good, it's negative. You could do either one. If you wanted to say add, but then you'd have to say plus negative 3, you could. Or you can just say x minus 3. Either way, same thing. And what are we doing with the y? Adding how much? 1. Beautiful. So this is all saying the same thing. So you can use any of these to actually graph. In ALEKS, some of them will be in words, some of them will be in vectors, so you'll just have to kind of know which one works best for you and how to translate it to that part. I always like words best. So when I see a vector, this negative 3 in my head, I'm thinking negative 3 left, 1 up. All right, so as we take a look, what we're going to do, we're going to take that colored pencil. I'm going to start on point Y. So start on point Y. And literally, I'm going to just count 3 jumps to the left and then 1 jump up. So 1, 2, 3, and then 1 jump up. And there's my new point. So I started at Y. And from Y, we're going 3 left, 1 up. Now remember, that's our image. How do I show an image? How do I label it? I want to tell my reader which point it came from. It came from what point? Y. But it's not the same as Y. We changed it. So we're going to say Y prime. Good. We do that little hyphen or apostrophe. So Y prime. Okay, and then we literally just do that with all the other points. So I'm going to go over to X. And with X, I'm moving left 3, up 1. So left, 1, 2, 3, up, 1. There's my X prime. Okay, then you can do W or Z, your choice. You can work ahead. You're literally just moving all these points, left 3, up 1. So if you want to work ahead. Good, I'm seeing a lot of heads down right now, which is good. That means you're doing it on your own. Z is left 1, 2, 3, up 1. And W is left 1, 2, 3, up 1. Okay, in your bins there's rulers, or if you just want to use a straight edge, something that's straight just to help draw, that can be really helpful just to make sure that the shapes look the same. Okay, remember that when we do a translation, then we should have congruent objects. Congruent means that they are the same. They're exactly the same. They didn't change at all. So the shape shouldn't change. It shouldn't look like the X is in a wonky spot. It should literally look like I cut this out and I moved it over. Okay? How are we doing? Making sense? All right. The next one, we have 2 images on here. We have 2 triangles. So we need to decide which is the triangle that's the before and which triangle is the after. So which one is the pre-image? Why the one on the bottom right? The apostrophe. Yeah, the tick marks. The W, Y, and X down here. I'm going to zoom in. Down here, this one doesn't have the apostrophes. Remember, the no apostrophes, the no tick marks, means it's the start. So our finish is the primes. Okay, so what we're going to do is we need to figure out how did it move. How do I go from X to X prime? Okay, so if I start at X, first I always like to go left and right, because we always like to do X first. How much to the left do I have to move X to get to X prime? Yeah, 4. If you want to do those little hops to show that we counted 4, you can. Or you can just draw the line going across, whichever works best for you. Okay, so it went 4, and then how much up does it have to go to get to X prime? 2. So as we find this, we always just want to go left and right, up and down, no diagonals, and we want to just go in 2 directions, so not like up, over, just left and then up, or over and down. All right, so in words, which direction did we go 4? Good, so left 4, comma, and then 2 in which direction? 2 up, good. Or you could say up 2, sorry, I switched it. Either way. So something I notice a lot on this problem on the test, which is in like 2 weeks, so chill out. The test is not soon. Relax, okay? On the test, what I notice is some students will have this, but they'll say right 4, 2 down. Okay, if you say right 4, 2 down, what mistake did you make? Yeah, which one's the beginning and which one's the ending? So making sure you know which one's beginning and which one's ending is important to know these left and up. All right, as a vector, we're going to write those 2 numbers with positives and negatives. Does the 4 come to first or the 2? 4, positive or negative? Y negative? Left, good. And 2 is positive. All right, I'm going to do this last one, but we're not done, so don't close your notes, okay? If you already did the last one, just pause. We have one last thing we're going to add, okay? So xy is going to change with x, what are we doing with our x? We're going to add or subtract? Subtract 4, and with our y, we're going to add 2. Good, I already saw a lot of you already did that without us writing it down. All right, what this means, and there's going to be a problem in your ALEKS, I just want to talk about it a little bit, where in ALEKS where you just get points, you're not going to have the graph. There's a couple things you can do with that. If you get a problem that just has points, if you want a piece of graph paper and you want to plot it down and actually plot the points and draw it out, you can. Okay. Another way to do it is if I say W, so let's look at this point W, what it starts with. What's my x and y of this W? From the origin, it goes right 1, and then it goes down 2, so negative 2. So to change that to W prime, this is where that arrow notation is really nice, is it tells us what to do. It tells us with the x to do minus 4. So we're thinking 1 minus 4. Which most of you, I think, can do that in your head. And if you can't, just use a calculator. 1 minus 4 is what? Negative 3. And what are we going to do with the negative 2? What does it tell us to do with the y? It tells us to do plus 2. So negative 2 plus 2. That's how we're going to get that answer. What's negative 2 plus 2? Yep. 0. And if we double check that with our work, is that where W prime ended up at? Negative 3, 0? Yep. So what I'm trying to tell you is that in your ALEKS today, there's going to be some problems where there's not a graph and you're just doing this part. Okay? If that part, you're looking at it and you're like, what the heck just happened? Ask for help. Okay?